GATE 2021 Civil Engineering Set 1 Question 49. A cylinder 2.0 meter diameter, 3.0 meter long and 25 kilonewton weight is acted upon by water on one side and oil of specific gravity 0.8 on other side as shown in the figure. The absolute ratio of net magnitude of vertical forces to the net magnitude of horizontal forces rounded off to 2 decimal places is. Reference to the relevant NPTEL courses or video has been cited. Coming to the useful data, to analyze hydrostatic forces on curved surface, we can take the example of this figure here. Let's say there is a water of density rho and the volume of water is P. Let's say due to the presence of water, some hydrostatic force dF is acting at some point. Let's say we can't analyze the whole area, so we have taken an elemental area dA here. If you take a point C here and draw a tangent to it, which is making an angle theta with the horizontal, so the dF force is acting normal to the elemental area. So if you draw a larger picture here, we can see that if this angle is theta and the force dF is normal to the elemental area, if this is theta and this elemental area is, let's say it is dA, this will be dA cos theta and this will be dA sin theta. If the force dF is acting normal to it, let's say the angle here will be 90 minus theta, and so this angle will be theta. So by simple trigonometry or by using force analysis, we can say this angle, this will be dF cos theta and this will be dF sin theta. Now if we analyze the horizontal forces and the vertical forces acting here, firstly we can calculate that what the dF is. We know that the pressure at a point in a static fluid is rho into G into H. So the force will be pressure into area. We can write it rho into G into H into area. So now if you calculate the horizontal forces, let's say horizontal forces Fh, that will be integration of dF cos theta. If you solve it, we get rho into G into H dA cos theta. Now if you take rho G H outside and we put dA cos theta here, we can see that the dA is the projected area on a vertical plane, means dA is this area. If we integrate this whole area, that will give us the projected area on a vertical plane. So we can write it Fh equal to rho into G into H bar into AP. So this is the first formula we will be using here, where AP is the projected area. Now if you write for vertical forces, that will be integration of dF sin theta. We can write it also rho into G into H into dA sin theta. Now we put rho into G if we take outside and we write H into dA sin theta. So we can see from the figure that this is the this is our total height where the hydrostatic force is acting. So if we integrate it, this whole area, that will give us the volume. So we can write vertical force will be rho into G into volume, where volume is volume of liquid above curved surface, where volume is liquid our curved surface, and for horizontal force AP is projected area. Now coming to the video solution part, we can see here that here we are given a cylinder whose weight is 25 kilonewton, and here we have water whose density is 1000 kilogram per meter cube, and we have oil here whose specific gravity given is 0.8. So we know that G of oil will be density of oil divided by rho of water. So from here, rho of oil comes as specific gravity of oil is 0.8, and if you multiply it with density of water, which is 1000, we are getting rho of oil as 800 kilogram per meter cube. Now we can see that due to the water, this much volume is covered, and due to the oil, this much volume is covered. So we take it as volume 1 and we take it as volume 2. Now due to the water, the horizontal force will be acting in this direction, so this will be our Fh1, and due to the oil, the horizontal force will be acting in this direction, so this will be Fs2, and this will be our total volume. So now if you calculate net horizontal force, let's say Fh, that will be Fh1 minus Fs2. So as we know the formula, Fh1 will be rho W into G into H1 bar into Av1 minus rho of oil into G into S2 bar into AV, whereas AV1 is projected area. We are given total length of cylinder is 3 meters. Now we will put the values here. Rho of water is 1000 kilogram per meter cube. Small g is 9.81. If we calculate H1 bar will be 1 plus 2 by 2 to its center of gravity. So H1 bar will be 1 plus 2 by 2. And if we calculate the projected area here, that will be 2 into, and length of cylinder in z direction is 3, so it will be 2 into 3 minus rho of oil is 800 into 9.81, and S2 bar will be, if this height is 1, this will be 1 by 2 into AV2 will be, if this height is 1 and in z direction the length is 3 meters, so that will be 1 into 3 because this projected area will be rectangular. Now if you solve it, we get a total horizontal force as 105.948 kilonewton. If FH1 is acting in this direction and FS2 is acting in this direction, because FH1 is greater than FS2, so net horizontal force will be acting in this direction. Now coming to net vertical force, that is FV, that will be FV1 plus FV2 minus self weight of the cylinder. FV1 will be rho W into G into volume 1 plus rho of oil into G into volume 2 minus 25 kilonewton. Now we put the values here, we will see rho W will be 1000 into 9.81 into volume 1. Volume of this much part will be area of this much part into length of cylinder. So that will be pi into 1 square by 2 because radius is 1 into 3 plus density of oil 800 into 9.81 into volume of 2 will be pi into 1 square by 4 into total length, that is 3 minus 25 kilonewton. Now if we solve this, we get force as 39.719 kilonewton. It will be acting upward. So here we have calculated FV, and this is our horizontal force FH. In the question we are asked to find the ratio of FB by FH. So here value of FB is 39.719 and FH is 105.948. So the value coming is 0.374. So for this we are asked to find the value in two decimal places. So the value will be 0.37. Reference to the relevant NPTEL courses or video has been cited.